Okay, perfect. So yeah, welcome to the second Lunch and Learn session actually about Cloud Connector. We had one about a year ago, I think, actually for the Core Platforms group because there was similar interest in kind of understanding what it's all about, how it works. So we kind of were thinking, because the Cloud Connector group split up into multiple teams, now that we have identified portions of Cloud Connector that also moved with the different team members into these new teams, it will kind of make sense to do maybe a bit of a refresher, also because a lot has changed since last year. And also to give a bit more of a nuanced perspective on some of its aspects, because especially with this audience in mind of the authentication group, the authorization group, and all the adjacent groups, also provision, for example, to kind of look a bit closer at some of the aspects that are now allocated to these groups. So that was kind of a good opportunity for us to kind of base a new session on previous work we had done, but give a bit more of a focused session or kind of a learning exchange on these various topics. And the way I kind of thought I'd break it up is it's quite a packed agenda, I think. I took some things out from last year, but I added other things in other areas. I think no single slide is unchanged. The way I thought I wanted to cover it is if you don't know anything about Cloud Connector, I still wanted to give kind of a high-level overview of what it actually does, what kind of problems it solves. But I don't want to just stay at this very high level. So next, I want to walk through how a specific feature, in this case, a code generation, is actually delivered through Cloud Connector so that you can kind of see full stack how all of these different layers are involved and interact to deliver a particular feature to the end user. And these two topics I covered last year already. I just condensed them a little bit more. What's new is we have learned a lot over the last year, so I think it would be interesting, especially if you plan to work on Cloud Connector, what the areas are in which it can break and how do we monitor these? Because that's, of course, super important. We run services in production, none that our team specifically owns. But we are, of course, involved often in incidents in which Cloud Connector is involved in some way, shape, or form. So that could be interesting for you to know as well. And then, of course, contribution. So when I did the talk originally, it was the Cloud Connector team. So we were pretty much the only people contributing to it. Now that we've distributed these responsibilities a bit more, we're, of course, hoping to expand this and get contributions from within the authentication group, but also beyond that. And finally, we're going to look a little bit at what are maybe some of the broken windows and also the opportunities in terms of what should we look at next. So let's start with the very high level stuff. Especially if you have never worked with Cloud Connector specifically, I think a very common misunderstanding is that it's not a feature or a product that we advertise or sell. It's really just we needed a good name to refer to basically a set of configuration and code modules holistically so that we have something we can talk about in aggregate. So Cloud Connector is what we termed this. But you should not really think of it as some kind of box that sits somewhere and delivers services. So it's not like a web service that you can deploy. So it's not really a single architectural entity. And I'm going to show you later a little bit what that means. So it's really distributed along a number of systems that interact somehow. And the main problem really it solves is to provide customers, primarily self-managed customers, but also customers on GitLab.com. They also implicitly use Cloud Connector to access features that are hosted in, I call it the GitLab cloud here. Think of it as really one or more services hosted by GitLab, the company, and not individual customers, so that they can set up hybrid systems. So if you're a self-managed customer, for example, and you want to host your own GitLab instance, maybe you're not super keen on running your own satellite services because that involves extra configuration, especially for AI. That was very challenging. That was the primary reason for the business to ask for a solution like Cloud Connector. But instead, some parts of Duo will run on your own GitLab instance, so on premises, and some parts of it will be run by us, by GitLab, the company. So I call this a hybrid setup. And really a key point was we wanted this to be plug and play, right? So the whole idea of convention over configuration. So basically just by virtue of you buying a certain subscription with us for Duo, it's Duo Pro or Duo Enterprise. Just based on that, it should just work. So you would be able as a self-managed customer to use AI in your GitLab instance. So uh, of course, yeah, so I mentioned before, this is not just for self-managed customers, but that was the main gap we needed to bridge, right? So you can use Duo on GitLab.com, of course. So where there is no instance administrator for a single organizational namespace. But basically, what we needed to solve in terms of a self-managed point of view is we have certain instance level permissions that are stored typically in Postgres. And what we needed to do is we need to translate these into cloud-based permissions. So basically entitlements that you get for what you can do when you make requests into systems such as the AI gateway that we run on your behalf, on behalf of other customers as well. So I need to minimize the Zoom controls here. Otherwise, I can't see my slides very well. Okay, that's better. By the way, can you see my mouse pointer? I wanted to make sure yeah, okay. So I think, so I mentioned before, so Cloud Connector is not really like a single entity or like a single system. So I thought maybe it would help to look at the different layers that are involved. I think this gives you a better sense for where we work, also in terms of repositories and systems, and kind of how data or information kind of traverses through these layers. If we start with the end user client, and that's typically an IDE, but it could also be a browser if you think of things like using Duo Chat in the browser or using the web IDE, and then you use a code, you receive a code suggestion, things like that. This is where Cloud Connector is typically not involved, right? So these, what's this color? Teal. So the light blue is where we kind of enrich these different layers with some sort of Cloud Connector specific logic. But it does not start at the end user client, but this is where the request originates. So especially since we have a lot of folks here from the authentication authorization groups, if you think in terms of how authentication works here, what we typically start with is with an auth token or a personal access token. That is, that's been around forever. That's not where Cloud Connector comes in. But we send this request and authorize it at the GitLab Rails instance. What then happens, this is what I mentioned on the previous slide, is we somehow need to translate these local permissions into cloud entitlements. And the way we do that is by consulting what we call the Cloud Connector catalog. And I'm going to show you in a minute what that looks like and what that means. But it's basically a mapping from how we bundle individual cloud entitlements with things that we sell, such as Duo Pro, Enterprise, the different license tiers, and so forth. And what we do is after the user is authenticated against any GitLab instance, be that on .com or in a self-managed environment, we translate this to a new kind of token, which is a JSON Web Token, which is Cloud Connector specific. And what we do is we attach it to any request, which then goes in the direction of upstream backends that are connected through Cloud Connector. So we attach this token, and what we first do is we do not actually contact individual Cloud Connector backends individually from a Rails instance. We route them through a specific Cloudflare zone, which is cloud.gitlab.com. And the reason we do is, so it's a proxy basically. And the reason we do this is it greatly simplifies setup logic for the customer, so they don't have to maintain allow lists for a bunch of different backends that they might want to use. So this was really important to make good on this promise of convention over configuration, and this should just work. Yeah, so in Cloudflare, we also do some things like rate limiting, but I'm going to talk a bit more about this later. So once this request moves through Cloudflare, we then hit the actual backend service where the cloud-hosted domain logic runs. So for Duo, that would be the AI gateway. We had two other cloud-connected backends. One was the GitLab observability backend, but that is not being worked anymore, so that's kind of paused. But we have another live backend that is the SSCS scanner, so where you can initiate security scans right from an IDE. So before I talk about how this all looks like in terms of like components and how they interact, I wanted to talk a little bit about tokens because it's really important to understand the difference between these. I think otherwise it might get confusing later on. So I mentioned already the tokens that we already use to identify end users, PATs and OAuth tokens primarily. These are distinct from Cloud Connector tokens. So when we, because they also, they kind of lose their meaning after the request is cleared in a Rails instance, and then business logic triggers, right? But if you allow the request to propagate further upstream, Cloud Connector specific tokens come into play, and there's actually two different kinds. Um, and I'm going to talk a bit later about why there's two kinds. For now, just know there are two different ones. One we call an IJWT, which is an instance scoped JWT. And this is our primary token that we use to authenticate calls, and that carries all the entitlements. And for some paths, we also have user-specific JWTs, which actually allows end users to bypass a Rails instance and go to a Cloud Connector service directly with this kind of token. So they're short-lived tokens with more narrow scopes. And you've probably all seen JWTs before, but I thought it would be interesting to see at a Cloud Connector example. So here's one for a self-managed customer, and you can see that it has an audience claim, which in this case lists the GitLab hosted AI gateway as a target. So any system that received this token that is not the AI gateway should reject this. We also have a token subject, which in this case is an instance UUID. This is the the GitLab instance ID that we generate when you first set up a database. So for instance, GitLab.com, the primary Postgres cluster has its own UUID, and so does every individual self-managed instance and dedicated instance. Then you can see the issuer here was the customers portal, and you will see later how that comes into play. We can also see that it was for a self-managed customer. We call that the GitLab realm in the context of Cloud Connector. The only other realm that we have is SaaS, by which we mean GitLab.com. And you can see it has a list of scopes, which translate to cloud entitlements. So for example, complete code is the entitlement you need to obtain a code completion from the AI gateway. I also mentioned we have an entitlements catalog, and this is used to determine which of these scopes actually end up in a token. And if you want to look at this, Nicola made this, he built this, he generated this. This website is actually generated from data that you can find if you click on source here. The slide deck is linked in the event as well, and in the agenda if you want to take a look later. So this actually links you to the repository where the underlying data for this lies, and we generate this website from this data, and you can then find it in this online entitlements catalog. And you can see here that, for example, for the code completion entitlement that I just showed, it has a description. It is allocated to a particular stage group, a feature category, etc. Also, things like which GitLab version do you need at least to use this feature? So that kind of gives you a nice overview. This is more for like internal consumption at GitLab. Yeah, and we just use that to propagate this information in a more human readable way. And if you look at the data source under this, you will see it's just a bunch of YAML files. And the way it's structured is primarily around the concept of a unit primitive. And a unit primitive is, you can think of this as an atomic entitlement that you can have in a cloud service and that we can sell with some kind of add-on. So you can see here that for code completions, we bundle it with Duo Pro, Enterprise, and Core. And you can also specify which services it targets. And this is then later translated into a token scope. Sorry, into the token audience. And these are these are resolved when we look up subscriptions in the Rails instance against the catalog and later to generate the token. Yeah, there's a bunch of metadata as well around which MR introduced it, whether it's deprecated or not, etc. So these basics out of the way, I wanted to give you an overview now of the different modes Cloud Connector can operate in. This is also a significant change compared to a year or so ago because we had a couple new kind of topologies or ways to operate Cloud Connector that we needed to support. So I'm going to go through them one by one now. The simplest one is actually GitLab.com, surprisingly, which is our multi-tenant environment. And what we do here is we kind of have the benefit because it's within the trust boundary of the GitLab, the company. We hold the keys to the kingdom there. So what we can do is we can actually mint our Cloud Connector tokens on the fly using a key that is stored alongside the Cloud Connector catalog in the Rails instance. It's just stored in Postgres. So basically what happens is on GitLab.com, if you request a code suggestion, you just request it with your PAT or auth token. And then on every request, we swap that for Cloud Connector JWT based on, there's a bunch that happens, things like understanding what namespace a user belongs to, does their namespace own the necessary add-ons and so forth. But if that all checks out, then we attach a JWT to the AI gateway request and yeah, and it goes that way. So pretty straightforward. And the way we validate these tokens is through OIDC key discovery. I also have a separate slide for this, but a lot of you are probably familiar with this because we serve that through our auth endpoints. And so it's we have a bunch of other use cases for that. Through these endpoints, we fetch the matching public keys to validate, so the AI gateway and other Cloud Connector backends can validate these tokens. So this is actually the most straightforward implementation. And this sort of existed before Cloud Connector was formed. Actually, the very early prototype for the AI gateway was already doing something pretty close to this. But this does not work with self-managed customers though. So if I were to just supplant this architecture into self-managed, you get a problem with trust boundaries. And the reason is that it's basically this here. So we cannot trust a private key that is deployed with a self-managed instance because it can be tampered with. It basically, the customer then holds the keys and we cannot just swap that for a token that allows us to, or allows the customer to make requests into a GitLab hosted AI gateway, right? So this is not going to work. So what we did was this. This is looks like a bit of a mouthful, so I'm gonna try to walk through it step by step to make it easier to understand. Basically, the idea of this architecture was that we delegate trust through an intermediate step through our customer portal. Because we know self-managed customers subscribe through our customer portal, we kind of have a single source of truth in I just call it C dot for short on these slides. So if you see C dot anywhere, that's the customer's portal, customers GitLab.com. Because this is a source of truth for which customer has purchased which licenses and add-ons from us. This is actually a great source of information to understand what should they be allowed to do. So what we did instead was the following. So the first step is the same as we had on GitLab.com. So you just request your code completion. But now this is within the, might be on premises with a specific customer, right? So their own users in their own IDEs request a code suggestion to the self-managed Rails instance. And instead of creating a JSON Web Token on the fly, what we do is we actually load it from the database. Well, how does it get to the database? We actually run a regular synchronization job through Sidekick, which fetches this access token, which is, it has a customer scope, so it's good for the whole instance. So we fetch it from CDOT in exchange for the customer's license key. Because if we have their license key, we know they're a paying customer, we know what they paid, so we can actually mint this token over here in the customer portal using a private key that we own. and using the same catalog data that we use elsewhere. So we can ship the resulting token along with the catalog data through Sidekick into all of these self-managed customer instances. So they constantly contact us to update this information. And this token is good for a couple of days. So even if a sync fails, like it will still be good for a while, but it's then rolled over regularly. Other than that, the rest is the same, right? So we will take that token, attach it to requests upstream. And the only other change here you can see is because still we need to be able to validate these tokens. So the AI gateway performs OIDC key discovery, not just with GitLab.com, but also with the customer portal. So there's two sources it fetches keys from, and it does that regularly. So there is a new use case that arrived and went GA in February, which is Duo self-hosted. That is another mode we need to support. And this is also for single tenants. But it's slightly simpler because this architecture here, it's this hybrid setup that I touched on, I think on the first or second slide, right? So because some parts are self-hosted, like your Rails instance, for example, and other parts are cloud-hosted by us. Whereas in this environment, we had some customers express a concern about things being hosted by GitLab and the information that moves around there. So they would prefer to actually take on the extra deployment and operational complexity and host their own AI gateway specifically for Duo. I believe we only support that for Duo and the AI gateway at the moment, so not for SaaS scanning. But I think the intention is to eventually have self-hosted capabilities for more than one backend. And I guess the nice thing about this is you can see this should look very familiar because it's basically the same architecture we use on GitLab.com. And this again has to do with trust boundaries because if the customer runs everything, every single component, we don't need to delegate trust. So we can just have them generate their own keys and still provide a zero trust environment where every node individually verifies permissions and yeah, verifies token signatures and so forth. We just supplant that onto the customer setup. This architecture looks simple because it looks pretty much like GitLab.com, but the devil is in the detail. I'm not going to talk about it now, but if you're interested in how exactly this works, it's actually far more complicated because of the nature of standing up a self-managed environment that also includes an extra service that we need to validate tokens for. So this is, I think, the last case I have, which I touched on when talking about tokens. So far in these slides that I showed you, where a Cloud Connector token moves around, those are what we call the instance scope JSON Web Tokens. So these are pretty powerful tokens because they basically hold the sum total of all entitlements that you get by purchasing products from us. So for example, if you would purchase more than one add-on for different kinds of functionality that you want to unlock, it would all be encoded in this one token. And for reasons of A, descoping this a bit more, and B, to improve performance specifically with code completion. So this architecture was specifically later added to support code completions. We also support a smaller kind of token called the user JSON Web Token, which contains a subset only of the entitlements that you need. And we can use it to let clients go directly to a Cloud Connector backend like the AI gateway. And I highlighted these new paths in yellow here. So what happens is that the IDE first needs to request a new token, namely the user JWT. And again, it just does that with a normal PAT. I took the token boxes out of this diagram because otherwise it was too crowded. So, but this is just your ordinary PAT that is attached here. And it goes to a Rails endpoint and says, hey, I would like to get a new token that I can use to directly go to the AI gateway so that you don't need to proxy every request through your Rails instance first. And what by the way, this is only for GitLab.com, but it works the same way on self-managed. I just wanted to give this as an example. So what the Rails instance then does is, again, it loads or creates an instance scope JSON Web Token, and it uses that to then request the user scope token, which is kind of downscoped through cloud.gitlab.com/auth, which will be routed to the AI gateway. And then the AI gateway has its own key set or key pair so that it can swap. So first of all, it can validate the IJWT that's being sent, and it can swap it for a smaller version of that token by copying entitlements over that are only good for a particular endpoint, for example, code completions. So it mints this new token, sends it back, and then finally the Rails app sends it back to the caller. And this allows the IDE to go straight to the AI gateway with this token. Actually, this is a bit confusing because, yeah, so on path 6, this would go to /AI, right? And for example, for code completions or other Duo features. Right, so that's all the modes Cloud Connector needs to support and can run in. I'm gonna take a quick break here to ask if there's any questions so far, or if I've already lost everyone.
One of the questions I had is, so we mentioned a bunch of essentially cases for how Cloud Connector is used. Who owns, if I was to go and make a change for any one of them, who owns test cases for them? Is it built into Cloud Connector today? Do we have them? Do we not? Is that not even Cloud Connector responsibility? Is it the consuming team to do them?
Yeah, that's a great question. I have a slide as well on ownership, but long story short is test cases for particular features are always owned by the stage groups because the mechanisms to enable these are always the same, right? So it doesn't really matter if you build chat, say, or the SAT scanner. At the end of the day, the way you obtain a Cloud Connector token is always the same for those. So what we do is we have a library that we can use to support these cases, and that is tested separately in a separate repository. But specifically, if you talk about end-to-end testing, because that is always a feature endpoint, right? So the feature endpoint would be something like, I actually have an example right here, right? So that I'm going to talk about, which is requesting a code generation. So that would not be owned by us or even our former team, right? That would be impossible because there are far too many of these that we could possibly own that. So that's always done by the stage groups. Does
Makes
that
sense.
answer the question?
It does, yeah.
Oh, excellent. All right, yeah, let's talk about an example to make this a bit more tangible. So I picked a code generation, actually, which is separate from a code completion. So if you were to do something like that was actually me doing that a year ago. So if you do something like implement FizzBuzz, what happens is roughly like this. The IDE will collect some contextual information from the editor and so forth. We'll send a request to Rails and it attaches your PAT, or if you're in the Web IDE session cookie. It will then go to the Rails app, which does the token swap from the PAT to the instance JSON Web Token. We then also need to, or actually before that happens, we need to check, can the user in general even access code suggestions as a feature? And I'm going to talk in a moment about what that means exactly. It then forwards the request to Cloudflare, which applies things like web application firewall rules and routes the request to the AI gateway, where we can then verify the integrity of the token and we can map it to an endpoint as well, right? So there will be code that says, oh, if you're trying to access the generate code endpoint, there needs to be a matching a matching scope basically in the token. And then finally, we can go to the actual AI model and stream the response back to the caller. One thing I want to point out here is if I blow up this box in GitLab Rails, you're probably all familiar with the declarative policy framework. What I want to highlight here is that Cloud Connector, conceptually, think of it as sitting beneath it. So what we should always do is we should enact any kind of policy that might also involve things like instance local state or settings, right? Because or even namespace bound settings. They can always be, for instance, administrators, they can say, I want to turn Duo Core on or off, right? So there are settings like these that allow you to control things that are also checked by policies. So these are always evaluated first, or should be. And only if those all pass and we kind of know who you are and we know, oh yeah, you can actually access this Rails endpoint, that's when Cloud Connector comes in. And that's when we start looking at things like your subscription history and entitlements. So yeah, if we talk about the pieces that are not Cloud Connector related, because I think sometimes, yeah, to draw clear boundaries, I think it also helps to know what is not part of Cloud Connector. It's basically anything that happens in terms of traditional authentication, right? And you all know that if you write a Grape endpoint, like a REST endpoint or a GraphQL endpoint, you will always deal with basic authorization checks that and also authentication, right? To understand who is the caller, what can they do, not Cloud Connector. Also, any permission settings that I just mentioned, declarative policy checks. Also, things like seed assignments are important. That's actually a common source of error. Like when something doesn't work, and then, oh, I forgot to assign the user a seed for the Duo add-on, right? That's something the administrator handles usually. But that is also a permission, basically, right? Without a seed assigned to both the license and a particular add-on, you're also not allowed to use an AI feature in this case, but that's not a Cloud Connector thing, which is why I mentioned this specifically. Also, things like capturing usage telemetry, not a Cloud Connector thing. So this is always up to stage groups. Like if you want to know how many users use, yeah, code completions or chat in every given day, that's not something our team would look after. What we do is anything around, and this I mean, with this I mean not specifically the authentication group, but Cloud Connector as an aggregate. What we do is anything related to the entitlements catalog, because here in this case, a user asks to generate code. So what we first need to do is we need to locate this entitlement in the Cloud Connector catalog. And depending on the environment, this might be either an in-memory lookup, actually. So if it's a self-hosted environment or on GitLab.com, we ship this through a library. So it's actually just a hash map lookup in memory. Or if you're a self-managed customer, it's part of the data synchronization steps. So we would look it up in the database. And based on this, if we can find this unit primitive and we can locate active subscriptions for it on this instance, then we say, okay, now you're allowed to pass, and we obtain or we provide an access token that matches these entitlements. And it will, in this case, carry the generate code scope, among others. What we then do is we generate this URL, which you can see goes to the Cloudflare zone for Cloud Connector, and it goes to this AI prefix. And I'm going to show you in a moment how that is resolved. And then it goes to the endpoint of the backend that serves this particular feature, in this case, code generations. If you're not familiar with Cloudflare, I thought I'd give a super quick summary of what it even does. Cloudflare is actually a suite of products. It's a service provider we use for a whole bunch of things that relate to edge networking issues, such as CDN functionality. So it provides us with global points of presence, where they basically stand up caches around like web caches around the world to accelerate content delivery. They also have this zone-based model for DNS record management. So that's how we get hold of the cloud.git.com domain that we can fully control through Terraform modules. It also takes care of traffic steering. So it can do things like if it detects a DDoS attack, it can dynamically route traffic away from affected backends and spread it out a bit. So yeah, it has a whole bunch of features that are very useful to have whenever you have a service that faces the public internet to protect resources. And actually, one of the most important points for us as well is we use it as a reverse proxy, right? Because it sits in front of Cloud Connector backends, and it's a fully proxied model. So it actually terminates the connection, runs through a bunch of logic such as routing and rate limiting, and then reopens the connection upstream to the Cloud Connector backend. So in this case, what would happen is it would detect, so the proxy that we run in Cloudflare, it would actually detect that this /AI prefix is mapped to the AI gateway, which is hosted on Runway. It doesn't need to be, but I think nowadays all of the two Cloud Connector backends we have are all hosted on Runway. So it basically rewrites the HTTP request by stripping out this path prefix, and then it turns it into this URL. So it actually changes the HTTP request, yeah, so that the client actually ends up dialing AI gateway runway GitLab net, but it preserves the actual request path, right? So that we don't mess with the actual payload that needs to be delivered. And this is not specific to code generations and this example here, but if you were wondering, does that work with gRPC and how? Yes, it does work. It took a while to make that work. But Dylan and his team working on Duo Workflow, they worked with us to add gRPC support. So basically a service call in gRPC is the path prefix, and then the actual RPC is the path, and that's then multiplexed over HTTP2. It also applies rate limiting rules, which used to be fairly complex. We used to have this kind of complicated approach to sort requests into buckets based on how many Duo seats the customer had purchased to give them a larger proportion of request share, because we do run shared backends, right? So all of our customers currently share the same set of AI gateway instances, and that might change in the future, but that's how it is today. But after we launched Duo Core, we realized that was not actually in our benefit anymore, so we simplified it all again, and we actually have quite simple rate limiting rules in Cloudflare now, where we just give a fixed budget to every user we can identify this way. Right, so once the request traverses Cloudflare, then it enters the AI gateway. And here it will be handled at the particular endpoint handler, in this case, V2 code generation. It will parse it, JWT, verify that it's legit. And it does that using the keys obtained from GitLab.com and CDOT, which I mentioned earlier. And of course, that it actually contains the generate code scope. We also verify a couple other request headers just to make sure it's not tampered with, such as that the UUID is still intact and things like that. Otherwise, there's ways you could potentially spoof the request or impersonate another customer and things like that. Right. Yeah, and then we actually carry out the AI vendor request. So that's how a code generation would be delivered. In terms of OIDC, you are probably familiar with it if you are in the one of the auth groups. If you're not, basically what we do is we use it to obtain a JSON web key set. And currently for Cloud Connector, this just happens through the endpoints that you might have already seen for other use cases hosted at OAuth/discovery, which is implemented through Doorkeeper, the Ruby gem. And we have code for this in the Cloud Connector library, where we also maintain the catalog config. So for the AI gateway, they actually link against the GitLab Cloud Connector Python library, which then implements this key fetch through OIDC. And the AI gateway or other backends as well, like the SAS scanner, they will then cache these keys for some time. We can't do this on every request. That would be too costly. I think it's about like 24 hours or so usually. And we roll them over every 6 months or so. Yeah, and this is basically, one of the key aspects that provides us with a zero trust implementation, kind of regardless of where we run it. And that's the final program as it was returned. And it worked. Okay, so any questions about the example? 20 minutes left. I need to accelerate. This is a new section I added because I think it would be interesting as well to see. We didn't have a ton of experience a year ago still running Cloud Connector, and now we have a bit more. So we kind of understand a bit better how it can break as well. So I thought it would be interesting to share some of these cases that I've seen happen. And not frequently, that would be overstating the issue, but we have some of these have been recurring. So I think these are the themes basically that we see where Cloud Connector sometimes falls over. The first one is that we see requests just fail to authorize in a backend service. And it can fail in two different ways. Either you just get a 401 unauthorized, or you get a 403, which I think is forbidden. And these are for two different reasons. The first one is there's something wrong with the token or the keys. Either the token is malformed or it has been tampered with, so the signature doesn't work out. That would be a 401. And that's a very common issue, especially in development, when people set up their systems. The wrong JSON web key set was fetched, maybe from the wrong source. Maybe you're fetching from staging instead of production or vice versa. So it actually fetches and caches the wrong keys, and then you cannot validate the tokens you set. That's also a 401. This typically doesn't happen in production, but is something you might see when working with Cloud Connector locally. If it's a 403, it's usually something wrong with the entitlements. So things like it should have an entitlement encoded in the token, but it doesn't. And then the AI gateway will say, no, you're not allowed to access this. So it renders a 403. And this can sometimes just be down to bugs, right? Or problems with entitlement synchronization. So there can be a number of reasons for why that happens. Which brings me to the next point. Other issues we've seen was with actually storage. So this actually mostly applies to self-managed environments where storage is an important aspect in synchronization. So we have seen things like race conditions in data synchronization. So where the customer updated their license, but then Cloud Connector data, there was a data race with Cloud Connector catalog data, and then Duo wouldn't work. And this sometimes can also be combined with caching. So if we were caching things in memory, that would then require a server restart if that data was wrong, right? Which is not super easy to understand for a customer, like why it isn't working. So we actually had a couple of regressions in Cloud Connector Ruby code around caching things too aggressively because we cannot parse, for performance reasons, we cannot parse the entire Cloud Connector catalog every time we receive a request, right? Yeah, or just stale data, like that can also happen. We also had cases where it looked like customer instances weren't talking to us anymore, so they just stopped like checking in with us for some reason. So their psychic jobs were like refusing to work. So we had a problem there with cron jobs that we hope we fixed. Sometimes that's hard to verify because it can take a couple milestones to roll out. Yeah, and that would then, for instance, break the c.sync, and then you get a stale token or a stale catalog, which causes authentication failures. We also had a couple performance issues, but it's kind of the opposite of the caching thing. That's the whole like the two-edged sword here, right? If you cache too much, you might risk stale data. If you don't cache enough, you get performance issues. So we had two cases of performance regressions that went unnoticed, where we were accidentally redoing work that we shouldn't be doing. Things like loading keys, which can be expensive. Also, what's a constant issue is the Duo health check. I don't know if you've used it a lot, but if you go to the admin area when you develop locally, under the Duo page, there is a health check it performs to see, can I reach the customer portal? Can I reach the AI gateway? Do you have a valid token? Are your access credentials synced? All of that. And this actually turned out to be super tricky to implement with all of these different environments and types of customers and use cases we need to support. So that is still not 100% working for all of these cases. The good thing is we have a new owner for this, the custom models group. They took this on now as part of the whole Duo configuration story. Right. In terms of ownership, because Adil also asked about this. So once when our team broke up, of course, we thought about, well, who do we hand over which part to, so that we continue to work on these things and maintain them, right? So for the authentication group specifically, this is largely anything that's to do with key and token management. So all of the things I talked about with minting JSON Web Tokens, key discovery, key rotations, that would be an authentication group. Anything related to the entitlements catalog and also the data synchronization between the customer's portal and customer GitLabs, that would be in the provision group under fulfillment. Then I just mentioned health checks is part of Duo configuration now, which is then now in the custom models group. Custom models, in the docs, we refer to this as self-hosted models. So if you see references to SHM or self-hosted models. That's the same thing. And then we have all of these infrastructure pieces around Cloudflare, which have shrunken a lot actually after we simplified rate limiting. So there's not a whole lot left there, but that has moved to production engineering and the runway group. Right, and yeah, we recently updated the guidance around this in the handbook, so you can also go take a look at that here. Yeah, so if you wonder like where does the authentication group specifically? I know there's other people in the audience, but like we originally thought about, well, where do we get involved? Where I was hoping, Alexei and I will get help in the future, which it doesn't happen very often, but if there are cases, it's broadly you can say it's usually if customers see authorization failures, that's probably something that we need to look after. And I mentioned some of these examples already. Token not sent because it was expired or a wrong key was used. Yeah. I think I touched on these already, so I'll skip over that. So how do we triage issues? We actually improved observability quite a bit, I like to think. It was not in good shape a year or so ago. We barely had anything. So nowadays we do have alerts for at least the AI gateway around OIDC key synchronization. That is something to that's important to stay on top of, because if that starts to fail for a prolonged time, so for more than 24 hours, basically, all AI requests will fail because we will not be able to validate Cloud Connector tokens anymore from anyone. So this is something to keep to stay on top of. So we made some moves to harden that logic a bit as well in the AI gateway to make sure, yeah, this is as likely to succeed as it can be, but it's not perfect. So there are still cases where we might get partial fetches. Sometimes we had cases like actually a super quick anecdote because it's kind of embarrassing that we didn't know this, but when our former team was not super familiar with how the customers portal operates, and the customers portal sometimes goes into maintenance mode, and there's a deny list you need to, or allow list, I guess depends on how you look at it. There's a list of endpoints that is part of the deployment of the customers portal, where you can exclude certain endpoints that are critical for operations to also go into maintenance mode. And we forgot to exclude the OIDC discovery endpoint from maintenance mode. So the fulfillment group turned maintenance mode on in the customers portal, which failed key fetches in the AI gateway. So I forgot if it was an outage or a near outage, but I think we might have noticed it quickly. But yeah, so a very simple thing, but which can have a really large impact on customers. So it's important to understand, like, also sometimes what can factor into these things that you might not even think about. Yeah, things also, of course, the backends might page on increased volume of client errors. That is not something we get paged for, though. That would be because the backend ownership is with the individual stage groups. So the AI gateway, for example, is owned, like formally owned and operated by the AI framework group. So if there's a page that goes out, it wouldn't reach our team, it would reach that team, but we will probably want to cooperate with that team to triage these. And that often comes down to scanning application logs and trying to understand, like, what is the error? And we put quite some effort into the Cloud Connector runbook to clarify this. There's actually a couple useful pages. You can look at that here. We extracted an authentication-specific runbook, actually, that highlights some of these cases. There's a flowchart as well that you can use to see what is the most likely cause for a particular error. And there's a separate triage handbook just for Duo as well, because it can fail in so many different ways, not all of which related to authentication. But it might still help to understand what's going on. All right. Last but not least, contribution. So of course, now that we're a bigger, or that we're more than one team and more people, hopefully we can start onboarding new folks on working on Cloud Connector. The way this unfolds, you probably saw this in this layer chart already. Some of it is in the main GitLab monolith. So if you have a bias towards working with Rails and Ruby, there's a couple domain objects that relate to Cloud Connector. and also library code in the GitLab monolith itself, particularly around synchronization logic that needs to run for self-managed and dedicated customers, and some GitLab COM specific paths. You all know these, if it's a SaaS feature of this or that kind, then run down this code path. So there's a bunch of those around Cloud Connector as well. And anything regarding the dual health check as well, and dual self-hosted, that would be in the monolith. We also have the customers GitLab COM integration. There's not a whole lot in here that is specific to authentication. There is some logic to mint tokens though, and there's an OIDC endpoint. We have an open issue for consolidating this more so that we can share more code between the monolith and customer start, because they're both Rails apps. That could be something to look at as potential contribution. Then we have the Cloud Connector library that I mentioned, which currently has a Ruby and a Python library module. The Python library module, I mentioned that already, is primarily to support the AI gateway. So we actually used to have two services, Duo Workflow and the AI gateway, which is why we extracted a library. And now we folded them back together. So now we have a library and one other repo that uses this one library. So we might be reversing that decision. We're not sure yet. But anyway, so it's the library right now. And there's also Ruby modules that help with, there's not a ton in there right now. It's mostly around a representation of a JSON web token that is shared between these two systems here. And finally, I suspect not many, if any, people will be on this call who would be working on this, but if you're interested, you can take a look at that. This is the piece we built for Cloud Connector in the config management repository to define the Cloudflare zone that we use, and the related routing rules and rate limiting rules. For development and testing, I have to say it's not super straightforward. I think if you've worked with Duo before, there's all these different ways in which you can run it. It's kind of difficult to locally reproduce a fully, like a hybrid setup as a self-managed customer would use. And it's even harder to locally simulate a self-hosted, like Duo self-hosted, where you also run your own AI gateway, your own custom models, because then you need to manage keys into AI vendors and so forth. So it can be quite complicated. Or Amazon Q is another example of that. But there is actually, I'm not sure if I linked it here, but there is actually a pretty exhaustive piece of developer documentation for Duo development in general. That's not Cloud Connector specific, but you can, I don't know if I linked it here, maybe. You can take a look at that and it will help you set it up. Yeah, other than that, these are all open source projects, so you can just make a contribution like you would do any other contribution. And we also have some documentation around how to test changes against the library if you prefer to work on the Python module, for example. Note that the development docs are quite outdated for Cloud Connector. We definitely need to redo them, but because we're in the middle of a larger refactor, so it's not a very good time to rewrite them. So we wanted to pull through with that first, and probably rewrite the docs once we're done. What's next? So outside of the really big topics that everyone is aware of, like cells, I think there's some specific areas I think that could do with some love, which is documentation, which I just mentioned. I think when we first wrote it, we didn't fully understand who the audience was. And I now think there is actually more than one audience. So I think as we rewrite them or rewrite this documentation, we should probably write multiple pieces of Cloud Connector docs depending on what you're doing. Like, are you building a new service that needs to be integrated with Cloud Connector? Or are you just working on a Duo feature that somewhere underneath uses Cloud Connector? Those are two very different kind of development personas, right? And we didn't really account for this very well when we first wrote that. Another thing that I hope will be fixed with the new auth framework is that we don't really have fine-grained permissions, because most of the time we will use these super powerful JWTs that basically bundle everything you buy from us in a single token. So that's something we need to improve on. Also, the decision to use a library was a very pragmatic one. because Duo is still where all of the attention is right now. So it serves us well currently, but our Go integration with the SAS scanner is basically the team had to build their own cloud connector integration and this whole OIDC dance and key caching, token validation. They had to build this all from scratch using open source libraries, which is unfortunate. So maybe we can do something smarter there, like deploying a sidecar with a runway service that will intercept requests and perform token verification there. Key storage and rotation is also something that is quite manual and quite risky right now. There's a runbook we maintain for this, but it needs to be carried out by a developer. And if you do it wrong, you cause an outage because if you do it in the wrong order or not at the correct pace, you might run risk that the backend loses access to the key to validate tokens that are still that are still distributed to self-managed customers. And finally, monitoring and alerting. We made some improvements, but it could always be better. All right, that's pretty much all I had. I made it with 2 minutes left. There's not a ton of time for questions, but if you do have time to stick around, I will stick around for questions, but feel free to drop off if not, and then you can just ask me async or book a one-on-one. Thanks, everyone.
Matthias, I had two quick ones that I will run for an interview, so I'll verbalize them and then I can catch up
Yeah,
after.
of course. Yeah.
First is, so you mentioned a bunch of libraries and how we ship Cloud Connector code essentially. If I was to look back and debug an issue to say, hey, I am on 17.11 and is this a bug? How do I go back to say, do I just look at the milestone and an MR is basically code going through the repositories where I can say, okay, this was fixed later on or not? Or do I also need to look at and say, okay, well, in 17.11, the Python library was on version X, and whether that has a patch or not, how do I work this out backwards? Because on monolith, it's pretty easy to say.
So I personally, the way I would go about it is to start with the symptoms and then work back from what I see is actually failing. And then based on that, try to understand, was there a change anywhere where that might explain why this problem occurred? And yeah, so we keep a release log to answer that part of the question. We keep a release log for the Cloud Connector Ruby and Python libraries. So with every milestone release, it will be pinned to a certain version. So you can just look that up and then you could just check out the tag for that library and then see, I don't know, was there anything in the last 5 commits or so that went out with this release that might explain that. So I think that's how I would go about it.
Okay, makes sense. And thank you for hosting this. I will run, but please stick around and
Yeah,
cover
sure.
questions as you can.
Thanks, Adil. Any other questions?
So one thing I was curious about is it sounded like the AI gateway verifies access based on the JWT scopes. So I was curious, you mentioned that the IJWT is valid for a few days, but what happens if like subscription expires or some other change occurs that would impact I guess those scopes in the JWT or their access? How
Yeah,
would that get handled?
that's a great question. So at JWT, we cannot expire it. It just expires based on the TTL that's encoded in the token. So that was actually and it was accepted by design. So we had a chat with product back then. We need to make some kind of trade-off here. It was kind of walking this line between we cannot make the lifetime so short that we might risk a single synchronization failure would cut off the customer from accessing Duo. That would be very upsetting for the customer because they pay us to access this functionality. But we also don't want to make the token live for so long that it, in case it leaks, it will be valid for weeks, right, for a potential attacker. So we kind of landed on this one synchronization cycle plus two, which was just a heuristic to say that seems like an okay middle ground. So yeah, that was just a decision we made, and we took that as an acceptable middle ground. That's the simple, if not if not particularly great answer to the question. I want to add, there was we had an epic up that was proposing essentially an iteration to the current design of Cloud Connector that was before the new auth framework was proposed, which we will now lean into because it's far more extensive. And in that new approach, we were actually thinking about the ability to handle situations like leaked tokens. Like if a customer would approach us and say, we had a security breach, the token was extracted, where we would have a security feature in Cloudflare itself, where based on some kind of list that we maintain of customer identities to say, reject any kind of request that's coming our way with this compromised token. But that was never implemented, so we don't have that.
One other thing that I was kind of curious about, I'm not super familiar overall with Cloud Connector, but I was wondering why there's a different implementation between self-managed and .com in the key generation for the JWTs. So I can understand it kind of with air-gapped, but for GitLab and GitLab.com and self-managed, I was curious why the different implementation.
No, that's another great question. This was also something that came up super early on. We did, again, have a discussion in an epic about this to consider streamlining the architecture. The simple answer is really it creates overhead that we don't want to have on GitLab.com because we need to be, so Cloud Connector is always kind of considered guilty until proven innocent when it comes to performance overhead, right? Because it's on every hot path for things like Duo. And we do spend time in each of these steps, right? For GitLab.com, that would mean we basically the GitLab.com instance, quote unquote, there's not a single one, right? It's the biggest GitLab deployment under the sun. It would have to synchronize with the customer's portal alongside all of these other self-managed instances that sync with us to sync in the same catalog data and an instance scoped token, which would then be attached to every request. That solves no problem at all, rather than being slower, right? Because we have this extra step that can fail that we need to maintain. And it's also more costly because we need to we need to basically do a database lookup every single time. So basically, we said that's just not worth doing. Again, this is something that once we lean more into the new auth framework, I think this will be solved because we don't have a concrete proposal yet for how this will look like. But what I hope will happen is that we integrate Cloud Connector under the STS in the new auth design, such that the STS will be able to evaluate all of the IAM policies, including those for Cloud Connector, which would then come from customers as a source, so that before the request even enters the Rails instance, and then it doesn't matter anymore if it's a self-managed customer or in GitLab.com, we already have all of the Cloud Connector entitlements encoded in that. That is kind of my ideal view of how it should work. And that would kind of obviate all of these issues because then we don't need to perform this token swap anymore inside in the application logic itself, right? Because it would all pre-exist in the session token that enters the Rails app, and we can just forward that to upstreams. And they will already sync keys with the SDS anyway to validate these tokens. So that's currently how I hope to solve all of these things by leaning into Gregor's proposal.
Additional thing that I would like to mention is that GitLab.com is not a single customer. So this would mean that we will not synchronize only one instance token, but actually all tokens for every namespace that exists there.
Yeah, exactly. Yeah, that's what. Thank you for clarifying that. Maybe that wasn't clear because that's also meant with the extra overhead. Think about the customers portal. I think it's run on 2 VMs right now. It's not a web scale application, right? It's very low volume, and it gets the occasional request spike from instances around the globe syncing with it. But that's not that much. But if you compare that to the number of namespaces we have, there would be a massive scale up in terms of extra traffic we would be sending there.
Makes a lot of sense. Thank you.
All right, then. Yeah, if there's no more questions, if you can think of anything, I would say just drop it in the agenda doc, or there's also a GitLab issue linked. You can leave your questions there or ping us on Slack. And thanks again for sticking around.
Thank you. It was very helpful.
Thanks
Thank
a
you.
lot.
Appreciate it.
Thank you.
Thank you.